So now that we've learned how to manipulate equilibria, we can use that and put these together for overall chemical reactions that involve more than one step. So the topic of this video is combining equilibrium constant expressions. So when you combine individual equilibria, you must multiply the equilibrium constants in order to obtain the equilibrium constant for the net reaction. So let's consider the following. So we have two steps here. The first is N2 gas plus O2 gas in equilibrium with 2NO gas. The Kc at 25 degrees Celsius for each of these is going to be equal to 4.1 times 10 to the minus 31. Our second reaction here is going to be N2 gas plus 1/2 O2 gas in equilibrium with N2O gas. Our Kc is equal to 2.4 times 10 to the minus 18. So what is the Kc at 25 degrees Celsius for the following reaction? N2O as a gas plus 1/2 O2 gas in equilibrium with 2NO gas. So we have to figure out how to first of all come up with this overall equation. So if we look here, N2O shows up as a reactant in our case here that we're solving for, and as a product in the initial set of reactions. The O2 gas shows up here and in two places up here. The NO gas shows up here and also shows up here, both as a product. The nitrogen only shows up in these first two equations right here, and that indicates to us that it will be an intermediate. So in order to get each of these here, we're going to need to do two things. We're going to have to reverse reaction number 2, and we're going to have to use then reaction number 1 and add them together. So if we reverse reaction number 2, that gives us N2O gas in equilibrium with N2 gas plus 1/2 O2 gas. The Kc for this expression is going to be 1 over 2.4 times 10 to the minus 18. Because remember, when we reverse a reaction, we need to do the reciprocal. The first reaction then is going to be N2 gas plus O2 gas in equilibrium with 2NO gas. So the Kc of this is going to be 4.1 times 10 to the minus 31, which is what we have here. Now we need to add these two together. The nitrogens are going to cancel out. We have N2O gas over here on the left-hand side. We also have an O2 gas, but we have a 1/2 of one over here. So this is going to cancel out with that, and we're going to have a 1/2 left over here. So we have N2O plus a half O2 in equilibrium with 2NO gas, which is what we were asked for. And now we have to figure out what the Kc of this is. So if we're determining an equilibrium constant for a net reaction that's made up of two or more reactions, the Kc, or the equilibrium constant, is going to be the product of all of these equilibrium constants. So it's going to be 1 divided by 2.4 times 10 to the minus 18 times 4.1 times 10 to the minus 31. When we go through and multiply these out, our Kc is going to equal 1.7 times 10 to the minus 13. And this is going to indicate that this will not go forward very far, and it's going to favor the reactants. So when you're combining two equations together to get a net reaction, you have to be able to manipulate the steps of that reaction, use the same tactics that we did in the previous video. Then when we add up all those equations, when we add our two equations here, we're going to multiply the K values to come up with our overall K for the net reaction, which in this case is 1.7 times 10 to the minus 13.